morning students. Today we will discuss about the addressing modes in computer system architecture. And yesterday in the last class we discussed about instruction. Now we will briefly go through whatever we studied in the last class. Instruction, as we discussed, was a medium through which we direct the computer to perform certain operation. Instruction set architecture acts as an interface, isn't it? So, this is user. In order to do some operation, in order to perform any arithmetic or logical operation such as addition or subtraction, we need to activate ALU, isn't it? ALU has to perform, that is hardware. ALU has to perform the addition operation. Now, in order to make ALU work, we need to give instruction through which the ALU will understand that yes, I have to perform certain operations. Now, these instructions contains an opcode and operands. Now, the number of fields in an instruction may vary. Okay? So, there may be several operands. Suppose in case of a binary operation, suppose you are performing addition. The addition is denoted by opcode. That is, the type of operation is denoted by opcode and the number of operands is denoted by the operand field. Okay? This is pretty much the format of an instruction. So, what does an instruction consist of? Instruction consists of opcode. Opcode denotes the type of operation. And operands are the numbers on which we have to perform the operation. So these field denotes the address of or direct value of operands. So first of all, why do we need an instruction? We need an instruction to direct the computer hardware that you have to perform certain operation. That is to say ALU or to say control unit that you need to perform modulo operation or you need to perform arithmetic operation. To make certain work, we do it through instruction. Now general instruction consists of generally fields such as opcode and operands. Operands may be several types of operands depending on the type of opcode. Opcode denotes the operation that we will perform. So various operations or arithmetic or be it logical, be it relational, whatever operation it may be, it is denoted through a proper opcode. And operands tell us about the numbers that we have to perform the operation upon. The numbers may be binary. In case of binary operation, we have to take two operands. In case of unary operation, we may need only one operand. So the number of fields in operands may vary. Okay. So now, how to get these operands from? Okay. How to get these operands? These operands may be present in memory. Now you can get operands from memory or you may also get operands from registers. Registers are present inside the CPU. Okay, we have very limited number of registers. We may have 32 number of registers or we may have 64 number of registers depending upon the architecture we are in. Okay, so various processes have various numbers of registers. Now depending upon the number of registers, suppose I say we have 32 number of registers. Okay. So operands may be present in the memory, that is in the main memory, or it may be present in the registers, one of the registers in the 32 register, or we may be talking about binary operations, so there may be two operands involved in which both the operands may be present in registers. Okay, so everything is determined by the addressing modes. So what is the topic of discussion today? How to know where to get the operands. Okay, where to get the operands depend on addressing mode. Okay. So how will the CPU understand where to get the operands by seeing an instruction? Suppose I have an instruction where the opcode is, the type of operation is add, and the operands are A and B. Now we have to perform addition operation. A plus B is the result. That is the work A and U has to do. So here we are going to perform addition operation. Now the operands are A and B. Now how to specify these operands depend upon the addressing mode. So generally we have 6 type of addressing mode. Okay. So we will discuss one by one, and each of the addressing mode will tell us how to derive the operands from. How to get the operands from, whether it's from a register or whether it's from the memory. Okay. So first of all, the first type of addressing mode is immediate addressing mode. Now what does immediate addressing mode says? Immediate addressing mode means that the operand is directly specified in the instruction. We no need to find it from anywhere. It is directly present in the instruction itself. Suppose the operation is increment or decrement, we may say. So I can write increment, increment 5. So this operation says that we have to just increment the value of 5. So the operation performed by ALU is increment operation. So 5 will be upgraded to 6. So 6 will be the answer given by ALU. So seeing this instruction, the ALU will understand that this is an immediate operand. Immediate operand means the number specified in the instruction itself is the operand. It doesn't has to go anywhere and search anywhere. Okay, so this is kind of immediate operand. So immediate addressing. So what is the format here in immediate addressing mode? First we have to specify the opcode, and the operand is directly given. Direct operand. Okay. So what is the format of immediate addressing mode? The opcode is specified, and which is generally a unary operator, and a single operand or whatever number of operands may be, but they are directly specified in the instruction itself. Okay. So next addressing mode is register absolute addressing mode. Now before moving to the absolute addressing mode, we need to understand that a operand resides in an address, of course. Suppose here A is a variable which has value 5. Now the file is stored in some kind of value, some kind of address, right? It is stored, if it is stored in memory, it has some kind of address. If it is stored in register, suppose R1, it is stored file. This also has some kind of address. Suppose the address here is 2000 and the address here is 5000. Suppose. So it has to have some kind of address. Wherever the variable or the operand is stored, that has to be stored in some address, right? Wherever it is stored, it has some kind of address. That address is called effective address. Okay? So what is effective address? Effective address is the address where the operand is stored. Okay? So address where operand is stored is called effective address. Okay? So this term is important. Why? Because we will be referring to this term in order to understand the rest of the addressing mode. Okay? So coming back to absolute addressing mode. Absolute addressing mode, the format is like this. Opcode. Opcode specifies the operation. Now, operand's effective address is given in absolute addressing mode. That is, absolute addressing mode specifies the effective address. So, suppose I give the address 5000 and 2000. Now, these are the effective address. The ALU will understand that in 5000 and in 2000, I have to fetch two numbers and I have to perform the operation as specified by the opcode. Okay? So, do you get it? The control will move to 5000. Suppose this is main memory and we have 5000 and the number here is suppose 8 and we have somewhere here, suppose this is 2000 and this is 5000. So here we have number 10. So CPU will move to 2000, fetch the number 8. CPU will move to 5000 and fetch the number 10. And suppose the operation is addition. Opcode is add, then it will do addition and give the result as 18. So this was about absolute addressing mode. So what does absolute addressing mode does? It specifies the effective address which has the operands. Okay. Now our third addressing mode is register addressing mode. So after the absolute addressing mode, we will cover next addressing mode as register direct addressing mode. Now what does, this is a kind of register addressing mode. From the name itself we can deduce that operands is definitely stored in registers. The operands are stored in registers. Now what does register direct means? Register direct says that this is opcode. The operands are directly specified, the effective address of the operands are directly specified in the register. That is effective address R1. So here the keyword is direct. Direct means R1 contains what? Effective address of operand 1 and R2 contains what? Effective address of operand 2. Okay. So these effective address will then tell us that in the memory where we have to go and fetch the operand. Suppose effective address, let's take 5000 and 2000. This is the effective address. Okay. So these are the effective addresses. So where we have to go 5000 and 2000. So this is 8 and 10. So as usual it will fetch 8 and 10 from the effective address specified in registers 1 and register 2 respectively, and it will do the operation according to the opcode specified. Okay. So I hope you understand this. So what does register direct addressing mode says? I will repeat it once again. In register direct addressing mode, in the register specified, it is given the effective address of those operands. Okay. Suppose register specified is R3 and R4. In R3 you will get the effective address of one of the operands. In R4 you will get the effective address of another operand, and this way, after getting the effective address, the CPU will fetch those operands and we will perform the operation as prescribed by the opcode. Okay. Now the next one is register indirect. So in register indirect addressing mode, it will specify the register will specify address of effective address. It will give some address 1, address 2, and this address 1 will give the address of, this address 1 will give the effective address of the operand. E1, address 2, E2. Effective address 2. Once you got the effective address, now you can fetch the operands, isn't it? So what does indirect addressing? It doesn't directly provide, the register do not directly provide the effective address. Rather, they give some address which is the address of effective address. Okay. So what does register specify as an indirect addressing mode? The register provide the address of effective address instead of providing the effective address directly. So I will just lay out the differentiation between direct addressing mode and direct register addressing mode and indirect register addressing mode. In direct register addressing mode, what happens is the register provides the effective address of the operand. In indirect register addressing mode, the registers provide the address of the effective address. Okay. I hope it is clear. If you have any doubt, you can post it in the query or directly contact me through my email ID. Okay. So we will continue in the next class with the other rest of the addressing mode. So for today that is all. We will continue with the rest of the addressing mode in the next class.